Good day, learners. Welcome to Technical Mathematics lesson. My name is Lumka Slwanyana. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Our topic for today is on trigonometry. At the end of this lesson, I want you to be able to apply trigonometric ratios in solving right-angled triangles in all four quadrants. You must be able to apply the sine, the cosine, and the area rules. You must know when to use whichever rule depending on the question and information given. You already know that when I'm talking about the trig ratios, I am referring to the 6 trig ratios, of which I'm having the 3 main ratios, which is sine, cos, and tan with their reciprocals. You know the reciprocal for sine is sec, reciprocal for cos, for cos is sec, and for sine is cosec, and for tan is cot. We use a short term to remember these main trig ratios. We use so, ka, to, wa, which help you to remember as to which side of a right-angled triangle is applying sine, which one is applying cos, which one is applying on tan. And when I'm talking about the cosec, which is the reciprocal of sine, I know it's 1 over sine theta. It tells you that there is a relationship between this one and that one. That's why we say it's 1 over sine theta. To make it easy for you, you must know that as you are writing sine as sine theta as opposite over hypotenuse, or you can say y over r. When writing cosec, which is the inverse of it, you are just swapping the two. It's cosec is r over y. You must remember that to make it easy for you, because I know some can be confused as to how do I work out with the 1 over sine theta, or 1 over cos theta, or 1 over tan theta. So those are the reciprocals. And you know that you can never use the trig ratios if your triangle is not a right-angled triangle. And your right-angled triangle has got your angle theta over there, as you can see, angle theta, and the sides are named according to your angle theta. You can see this side next to angle theta, this one, we refer to it as adjacent side. Adjacent to what? Adjacent to angle theta. They are named according to angle theta. We have this one facing this side. It's facing angle theta. So we refer to it as an opposite side because it's opposite to angle theta. If I can take the triangle, my triangle, in such a way that I have theta up there, and let's say this one is beta. Now I will have the one that was adjacent become an opposite side on that side, because it's opposite to that angle down there. And now the one that was opposite will change and become adjacent. So they are named in relation to our angle down there, to our angle theta down there. That's how we name them. And you will see when you are working with the those angles that help you to write or to remember those triangles. You will see sometimes you are changing and writing your opposite and adjacent in another side. Don't get confused. It's in relation to the angle that you are working with. So when dealing with the special angles, you will see them changing. When you are dealing with angle 30, you have your adjacent, the one that was adjacent when we were dealing with angle 60, it becomes opposite and vice versa. That's because of that. Don't get confused. All right, now I want us to apply trig ratios in solving right angle triangle. When applying trig ratios in solving right angle triangles, we are going to use the cast diagram. We are going to use the 4 quadrants. As you can see, the cast diagram over there is named in relation to the ratio that is positive on that quadrant, because you can see on the first quadrant they are all positive. Why? Because we are having a positive x. Our x there is positive, as well as y is also positive. And remember, your r, which is your radius from the center to the circumference of your circle or your Cartesian plane, is always positive. Your r is always positive. So in this quadrant, in quadrant 1, they are all positive, whether you are having x over y or r over x or x over r or y over r. Whichever ratio you are using, it's going to be positive on the first quadrant. That's why we say all of them are positive here, all 6 of them. On the second quadrant, you know that y is positive, is negative. We have a negative y over there, a positive y and a negative x. In this quadrant, only sine and its reciprocal that are going to be positive. Why? Because remember, I said to you sine theta is equal to y over r, and you can see that y is positive and r is always positive on all quadrants. It's always positive. Same as when I am dealing with cosec. Cosec theta, which is the reciprocal for sine, is also positive here, because I just swap whatever that I'm having for sine. I have r over y, which is also positive. My y is positive in the second quadrant, and my x is negative, meaning any ratio that involve the x in this quadrant will be negative, and those ratios are going to be cos and tan. Cos and tan are involving x, which is negative. That's why we find them negative on the second quadrant. On the third quadrant, we have tan that is positive. Remember, on the third quadrant, we have a negative x, we have a negative y. They are both negative. And in this quadrant, when I'm dealing with tan, I said to you tan theta and its reciprocal, it's opposite over adjacent. They are both negative, meaning I have my y over x. It's negative y over a negative x. They are both negative. And when you are dividing a negative by a negative, it gives you a positive. Same with the cot. Cot will also be positive here. Cot theta is a negative x over negative y, which give you a positive ratio in the third quadrant. And when you go to the fourth quadrant, you know that the fourth quadrant includes or involves x that is positive and y that is negative. We have a negative y. And when I'm talking about cos, you know cos theta is equal to x over r. And I'm having my x, which is positive, and my r, which I said to you is always positive on all 4 quadrants. So on the 4th quadrant, only cosine as well as sec that are positive on the 4th quadrant, because all the others are involving the y that is negative, which is going to make them to be negative on the 4th quadrant. Okay, now when we are looking at the, remember I said you will see that the sides are changing with the angles that you are using. When you are using special angles to help you to find the values, you are going to use the ratios according to the special angles, and you will be able to calculate. If you are talking about cos 60, you know cos 60 is adjacent over hypotenuse, which is going to be 1 unit over 2 units, so it's half. And when you are dealing with sine 60, it's going to be square root 3 over 2, and that is going to be seen on the special angles. And when I am talking about special angles, remember I said you are having the 60, the 30, as well as the 45, 45. In order for you to remember these special angles, you know that when you are having, let's say you are having 2 sides on a 30-60 triangle, you have 1 and 2. For you to find the 3rd side, you are going to use the theorem of Pythagoras, which is going to help you to find the 3rd side. Let's say you were having cos 60, which is 1 unit over 2, that is our hypotenuse. So I want to know, they give you, they say cos 60 degrees is equal to 1 over 2. You can tell here that I know my x, because I know that cos is x over r. I know my x and I know my r. There is a side that I don't know, and I must use my theorem of Pythagoras for me to work out the 3rd side. And when I'm using the theorem of Pythagoras, you know that it states that r squared equal to x squared plus y squared, where r is given as 2 and you square it, equal to the x, which is given to you as 1 squared plus the y that you don't know, y squared. And you know 1 squared is still 1. When you are squaring 1, you still get 1. And when you are squaring 2, you get 4. Now it means when you are solving for the y, you will transpose the 1 squared onto the other side, and you have 4 subtract 1, which is equal to y squared. Remember, the answer that you are getting is still a y squared. So for you to get to y, it means you subtract here, you have 3, which is still y squared, and you must have the square root of y squared, which is going to be plus or minus, depending on which quadrant that you are going to work on. And the answer that you are going to get there is going to be plus or minus square root 3. That is the value of your y, which you see there is square root 3. And that you find on the special angles. I have made a table for you there so that you can be able to see. When I'm talking about sine 30, sine 45, sine 60. And when I'm talking about sine 45, the one for 45, we are having the 45 and 45 on both angles, on the angle theta and my angle beta. They are both 45. That tells you that if I'm having the angles that are equal at the bottom of these two sides, those sides must be equal as well. That's why I'm having 1 unit as well as 1 unit on the other side. And when I'm calculating the longest side, it means I will use Pythagoras and say 1 squared plus 1 squared equal to r squared, which maybe I may have forgotten what is the value on the longest side using my special angle, and I get my square root 2. That is what I am using when doing the special angles. And if I can use the other values using cos, the sine, or whatever ratio, I'm using 1 unit, 1 unit, and you can see that if I'm dealing with 0, 0 over here is on the positive x. It means my coordinates here, if they can say cos 0, don't say, but we only know of 2 angles that are the special angles. They are taken from the Cartesian plane. The coordinates that we are having here on the Cartesian plane, I know my coordinates. I will have a unit on x, which is 1, and I will have a 0 for y. So it means my coordinates at 0 are going to be 1 and 0. And for me to find my r, you know that you are going to use the Pythagoras again. And you say 1 squared plus 0 squared, which is still 1. Meaning your r is going to be 1 throughout. Whether you are using 0, 90, 180, 270 or 360, those special angles, your r is always gonna be 1, and it's changing according to the axis that you are using. If you look at this side, when I am at 180, when I'm looking at 180, the coordinates over there, because remember I said I'm using a unit from the center to the circumference, center to the circumference. So I will have -1, which is the reflection of what I had on the opposite side. Because at 0, 180 is reflecting on 180 is reflecting on 0. So 0 is 1 and 0. And 180 is -1 and 0. Okay? Same as the y here. With the y using the same 1 unit, I have a positive y, which is 1, and the point over there on my circumference is going to be 0 at x and 1 at y, which is the reflection on 270, 0 and -1. Those are the special angles. They are so helpful, so you need to memorize them. You need to remember them, because for some trig problems, it is helpful to draw those diagrams showing the angles involved and the x, y, and r values on the special angles, like the 45, the 30, the 60. Okay, now let's look at the activity. Activity 1 that is given to us. They say, look at the diagram above and answer. In fact, it's next to the question. That diagram is given our angle beta with a point P. Can you see our angle? We have our angle moving in a in an anti-clockwise direction. So I have the coordinates of my point P over there as -5 and 3. It's on the negative x-axis with a positive y-axis, and the point P is -5 and 3, meaning there is a point that I don't know on my, if I can complete my triangle, and I have my right angle triangle in such a way that this is my R and this is my Y, this is my X. You can see I am given X and Y because my coordinates over there for point P are giving me X and Y. I don't know R. For me to work out this right angle triangle, I must find out the value of R, where I will be using the theorem of Pythagoras. So you can see that for me to calculate OP, I will firstly find the value using the theorem of Pythagoras and calculate R. The questions are over there. Let's quickly calculate the value of OP. OP using the theorem of Pythagoras, which is equal to our R. So OP squared equal to x squared plus y squared. And I have my x as -5, and I will square it. And remember, when using your calculator, don't forget to put the brackets, and you square, you put negative and the 5 inside. Otherwise, your calculator is going to give you a negative answer. When you press -5 on the calculator, I think I must show you on my calculator. When you say -5 and you square it, you will see that your answer becomes -25, and you are not supposed to get a negative value. When you square a negative value and it's squared, it means for you to have the answer that will be positive, you must put the brackets and you put -5 close and you square it. There you've got 25, a positive 25. So don't forget that. You square, you put inside the bracket, plus my y is 3. I have a positive 3 and I square it. So it means I will have 25 plus 9, which will give me square root 34 for OP, because my OP, the answer for OP squared is 34. And for me to remove the square, I square root both sides. So my OP is square root 34. Now they say without calculating angle beta, write down the value of sine beta in fraction form. Remember, your ratio is in fraction form. Your ratio is a fraction. So it means I come back, because I know my R now, I can complete my right angle triangle. I said my R is equal to square root 34. My X is -5. My Y is 3, which means when I calculate or when I'm writing the value of sine beta, I am looking at my ratio. I know sine beta is what? Is Y over R. What is my value for Y? My value for Y is 3. Looking from the diagram, you can see. and my r is square root 34. So my answer for sine beta is going to be 3 over square root 34. Moving on to question 3. Question 3 says I must calculate angle beta. Write down the value of cos without calculating angle beta. Write down the value of cos beta in fraction form. I want to know the value of cos beta. Remember, cos beta is what? X over what? Over r. And I've got my values on my triangle, right angle triangle, -5, 3, and my r I set is square root 34. So when I want cos is a ratio which involves my x over my r. So x over r, my x is -5 over square root 34. You can see that my cos beta is going to give me -5 over square root 34. And you can see that it is a negative value. It gives me a negative value because when you are dividing a negative by a positive, it gives you a negative, sorry. So because my diagram is on the second quadrant, there's no way I can have cos as positive on the second quadrant because my x there is negative, my r, remember I said your r is always positive. So it's my negative value over a positive value, which give me a negative, which explains what I said about the cast diagram on the second quadrant, where only sign is the one that is positive. If you get any other value or any other thing that is gonna be positive for cos beta on the second quadrant, you must know there is something wrong that you have done. Go back and recheck your work and see where you have gone wrong. Let's move on to question 4. Without calculating angle beta, write down cot beta. Remember I said cot is the reciprocal for what? For tan. Cot beta. Cot beta is 1 over tan beta, which I said to you, you can just make things easy for you. You know tan is your tan beta is y over x, which means your cot is going to be cot beta is going to be x over y, because I am swapping that. It is the inverse or the reciprocal for 10. So cot beta will be x over y. And what is your x there? Your x is -5 and your y is 3. Can you see again? You have a negative ratio on that quadrant in terms of tan or cot, because on the second quadrant you don't have a positive tan, you don't have a positive cot. It's only sign that is positive. Should you get anything other than what we have calculated, got there, it means you have done something wrong. Moving on right along, we need to calculate sine square beta plus cos square beta without using a calculator. Without using a calculator, we must calculate or find cos square beta plus sine square beta plus cos square beta. I have a y which is 3, an x which is -5, my r which is square root 34. So when I am substituting, it means I am going to take my ratios and substitute. I substitute sine square beta. My sine is opposite over hypotenuse. So I have bracket 3 over square root 34. And remember, it's squared. That is my cos, my sine beta, excuse me, plus cos beta. My cos beta is -5 over square root 34, and also it is squared. And when I am squaring, I'm squaring everything that is inside the bracket. I square the 3, which is the numerator. I also square the square root 34, which is the denominator. And when I square 3, I get 9. When I square square root 34, I get 34, because a square and a root, they cancel each other. Then there's no root anymore. Plus, remember they said without using a calculator. I'm not using a calculator here. -5 squared. Remember I said whenever I have a number that is negative and I'm squaring it, there's no way I must have a negative answer. It must be positive. Why? Because it's -5 times by itself. Negative times negative give you a positive 25. So I will have a positive 25 here over 34. Now they are having the same denominator, as you can see. When you are adding your fractions, you must check if you have your denominators the same. If your denominators are not the same, you cannot add the numerators. But in this case, my denominators are the same. It's 34 on the side for sine, and it's 34 on the side for cos. So it's the same denominator. I can just add my numerators. So I will get 9 plus 25, it gives me 34 over 34. And remember, you are not adding your denominator. You cannot say 34 plus 34 to get 68. You are just taking the common denominator there, which is 34. So you add the numerators, you don't add the denominator, you take the common denominator, which is 34. 34 over 34 gives you 1. So my sine square beta plus cos square beta is equal to 1. All right, let's move on to sine beta over cos beta. I have sine beta. Sine, remember I said sine is 3 over square root 34 all over cos. Cos I said is -5 over 34. And now in this case, when I am dividing the fractions, I change division into multiplication. So remember this line. This line is a dividing line. It's the dividing line. It divides. So when I'm dividing the fractions, I change the division into multiplication. And what next? I am going to swap these around. I swap them around in such a way that I will have 3 over square root 34 times, I changed division into multiplication as early as in grade 7, 8, 9. We were learning how to add or multiply as well as divide the fractions. So I have 3 over square root 34 times square root 34 square root 34 over negative 5. And I am multiplying without using a calculator. I can see that 34 and 34 cross out. I'm left with 1 here. I'm left with 1 here. 3 times 1 will give you 3 over 1 times negative 5 gives you negative 5. And you will notice that the value that you are having here is the value for 10, because 10, we know 10 beta is equal to y over x. You can see that's what we are getting. 3 over negative 5, which is equivalent to 10 beta. Moving right along, we go to question 2. They say now use your calculator. Use your calculator to determine 1 plus 10 square 87. Use your calculator to determine 1 plus 10 square 87. And when I want my calculator, I will go to my calculator and I am having 1 plus 10 square 87. You know 10 square 87, in your calculator you will put brackets, 10, 87, close, and it's squared. So your answer is equal to 365,089,777.3. That is the answer that you are getting. You have 365,089,777.3, meaning you round off your answer. You can round off to 2 decimal places, which is going to be 365,09, because the 9 that you are having there is the 8 is followed by a 9, which is above 5, and it's going to increase the 8 by 1. So you have 09. You can round off to the nearest whole number, which is going to be 365. Like that. The second one, you are calculating sec square 87. When I want sec square 87, they say I'm using my calculator again. My sec square 87, remember this one I said, you have 1 plus 10 87 and it's squared, which give us 365 degrees. For sec square, remember sec is what? Is 1 over what? Over cos. So for this one, I have 1 over cos 87. And it's squared. So coming to my calculator, I am going to press bracket 1 divide by cos, because I don't have sec on the calculator, 87, and I close and square. That's how you do it. Don't lose marks for free. These marks are for free. And it gives you the same answer as 1 plus 10 square theta. 10 square 87. So it means they are equivalent to each other. So it tells us that 1 sec square 87 is equal to 1 plus 10 square 87, because we get the same answer, which is 365 degrees. Moving on to the next question. The next question, question 3, they say calculate the length of MW in triangle BMW. It's not the car that you are driving, but it's the triangle that we are working with. It's triangle BMW, where I am given only one side. I am given BW as 8 meters, but I don't know MW, this side. I don't know it. And I must remember which ratio includes the adjacent side as well as my R over there. The ratio that includes or involves the two is the ratio of cos. So it means I am going to use cos 30 because my angle there is given as 30. So I am going to use the relationship between the two, which gives me cos. So I will have cos of the angle 30 degrees equal to what? Equal to BW over MW. Can you see the one that is in question is there? I cannot just take any ratio. I cannot take sine. Why? Because sine will be MB. Okay, anyway, I can still take sine. I can take BW because sine will be this side over this side. But the only trick that I'm having now, I don't have the value for MW, which means I will have two unknown values. Then I'm stuck. I don't know what to do. So cos is out, as well as 10 is out. Why? Because 10 is not including the MW, this side. 10 is only including this side and the given side. So what am I solving? I am not solving anything because I'll be leaving the question unsolved if I take 10 or I take sine. So the best ratio to use is cos of the angle. Cos 30 is BW, which is 8. I put the values now. Cos 30 degrees is equal to 8 meters over MW. And I must calculate for MW. For me to make MW the subject of the formula, can you see it's at the bottom here? It is a denominator here. So I must remove it there by doing what? Multiply both sides by MW. Multiply both sides by MW. So MW is gone there. I'm left with MW this side, cos 30 degrees equal to 8. And now, because I'm solving for MW, I must make it the subject of the formula. Remember, I said it multiplies here, which means when I am removing it there, I must use the inverse of multiplication, which is division. Divide with it both sides. Get rid of cos, because it's the one that is blocking me from having MW alone. Cos 30 is gone. I'm left with MW there. And I press my calculator to find what will be 8 over cos 30. 8 over cos 30. I get my answer as 16 root 3 over 3. And I simplify to get my answer as 9,24. So my answer becomes 9,24 because the question said I must round off to 1 decimal place. So my MW will be equal to 9,2. I cannot take 4. Why? Because the question says I must round off to 1 decimal place. So my MW is going to be 9,2 meters because everything is in meters. Moving on to the next question, question 4. They say if x is 70 degrees and y is 20 degrees, determine the value of cos x plus y. Determine the value of cos x plus y. Still on that activity, we want to know the value of cos x plus y. Question 4. What I do first here, because I have the values, they say my x is 70, my y is 20. My x is 70 and my y is 20, so I will substitute cos bracket 70 plus my y is 20 degrees, and I start inside the bracket, I add the 2, I get cos 90 degrees, and I have cos 90 degrees. Remember, I said when you are calculating this one, you can use your special angles. I know on my special angles, I have a unit here as 0, and this is 90. 0 and 1. My x is 0 and my y is 1. And obviously, my r is going to be my r. This is my r. This one. My r will be equal to 1. So when I want to know my right-angled triangle, there of 90, I will have my x as 0, my y as 1, and my r as 1. So when I'm looking for cos 90, I know cos is adjacent over hypotenuse. So my cos 90 is going to be 0 over 1, which is equal to 0. If you get 0 out of any value, your answer is still 0. So with the aid of special angles, I am able to find my value for cos 90, which is equal to 0. The next one, I must find cos x plus cos y. Look at this one. Now, they are separated, x and y, by what? By the plus, which means I cannot say add 70 plus 20, like I have done on the one above there. I must find cos 20 and I must find cos 70, which will give me the value. So I must firstly substitute the values. Cos x, x is 20, I will say cos 20, plus cos y, cos x, my x is 70, so it's cos 70 degrees, plus cos y, cos 20 degrees. And now I can just press this on my calculator. Cos 70 degrees plus cos 20 degrees, and I get something different from what I have there. Let's see it. Cos 20 plus cos 70. Your answer becomes 1,28. 1712764, which is different from cos 90, meaning you are not calculating them the same. So cos 70 plus cos 20 will give you 1,28 and many other numbers, which I can round off to 2 decimal places. They didn't tell me. I just round off to 2 decimal places, 1,28. That is my cos x plus cos y. Moving on to question 5. They say, if sine theta is equal to 12 over 13, determine sec theta without using a calculator. Meaning here I must find out from this ratio what is given so that I can be able to draw my triangle and identify the correct quadrant. Because I'm having sine as a positive value, sine, which is my sine theta, which is y over r. That tells me the values that are given. I am given the value for y. I'm given the value for r. They say what is y? Sine theta is 12. That is my y. And my r, they say, is 13. So it means I don't know r here. And for me to answer for sec theta, I must have the r. So I must use my theorem of Pythagoras and calculate my r, where I will say r squared equal to x squared plus y squared. My r, I said, is 13, and it's squared, equal to, what else am I having? I have y, I don't have x. X squared plus my y, which is 12 squared. And my 13 squared is 169, equal to x squared plus 12 squared is 144. And when I transpose, I take 144 to this side, it becomes a negative. So I have 169, subtract 144, and it gives me the value for x squared, not x, which is 25. And my x squared is 25. And remember, I have a positive sign, meaning my sign is a positive 1. If I have my y positive, my r positive, it tells me that I'm either having my sign on the first quadrant or on the second quadrant. So I will take it, it's on the second quadrant, where my x will be negative. So I will have, therefore, my x will be plus or minus 5 when I square root both sides. If it's on the first quadrant, it's a positive 5. If it's on the second quadrant, it's a negative 5. So I am going to take this one, whichever that you take. You can be able to calculate your sec. Sec is the reciprocal for what? For cos. So my sec theta will be, remember, sec is the reciprocal for cos. It's 1 over cos, which is y over x. As you know that cos is x over r. It's r over x. My cos is x over r, so my sec will be r over x. And I go back to my triangle that I have drawn there, and I have my sec. My x, if I'm using the second quadrant, I can have two values here. My r is always positive. So my sec theta is going to be 13 over negative 5 if I'm using the second quadrant. If I'm using the first quadrant, I will have 13 over 5. That is my value for sec theta, because there's no restriction as to where theta is an angle of which values. So I am using either the first quadrant or the second quadrant. Why? Because my sign over there is positive, is not negative. All right. Now I want us to apply sine, cosine, and area rule. You can use only trig ratios if you are having a right-angled triangle. If it's not, you cannot use the the ratios, but you can use the sine rule, the cosine rule, the area rule to find the length of the sides, the sizes of the angles, as well as the area of the triangle. You know, when you are calculating the area of a triangle, area of a triangle is half base times height. But if you don't know which one is your perpendicular height, which one is your base, so you can use the what? The area rule. If you don't know the sides, the information that is given to you doesn't satisfy or is not complete as to you must use that formula. You opt for the what? For the area rule. Or if you don't have a right angle triangle where you won't be able to identify as this one is my opposite side, this one is my adjacent side, this one is my hypotenuse, you cannot use the right angle triangle to find the sides. Or you can just use the what? The sine rule or the cosine rule, depending on the information that is given. When do we use the sine rule? Okay? If you have enough information about the sides and the angles, you can use sine rule to find the other side and the angles. And for you to use the sine rule, you must have your triangle. Let's say you have triangle ABC. Triangle ABC. And you can see that I am naming the angles with the capital letters. When I'm naming the sides, I am going to use the value of the angle that is opposite to the side, and I name it as a small c. And for this one, I name it as a small b. And for this side, I name it as a small a. So for the angles, I use capital letters, and for the sides, I use small letters. So for me to use the sine rule, I must at least be given either a full pair of the side and the angle, the side and the angle, and the other one, maybe I can be given the angle and I don't know the side. I must find the side. Or for A, I'm given the angle, I don't know the side A. Or I'm given the side, I don't know the angle A. And the formula that I'm going to use, I can use sine A over A, can you see, over the side. Sine of the angle over the side equal to sine of the angle B over the side B, equal to sine of the angle C over the side B. Or you can write them vice versa. You can start with the side over the sine of the angle. That is the formula that you can use. Where someone is using this one or someone is using this one, it's still the same as long as you are having the information that is given enough for you to work out. And remember, I said to you, in order for you to use a sine rule, you must have a full set of the angle and the side, so that when I am saying A over sine A, I have the value of a sine the angle A as well as the side over there. If I'm using this, if I'm given this one, I must be given the angle B as well as the side. Even if this side I am given the angle, not the side, I can be able to use the sine rule. You must have one complete side and like this. This one must be given full. If you are, let's say, you are calculating for side A, you must at least be given a full set of angle C with the side C, and you must be either given a side or the angle for A. Same as for B. You can be given either the angle or the side, and you are working the other one. Then you will be using the sine rule. We can write it like that. So the matching opposite angle must be given as well as the matching side, and one more side or the angle. That is the sine rule. Remember, I said I am writing my angles as the capital letters. You can see this is my angle C, this is my angle A, this is my angle B, and I'm using my lower cases for the sides because this side is facing or is opposite angle A. I use a small letter A. This one is opposite angle B. I use small letter B. This one is opposite angle C. I use small letter B. For sides, A over sine A equal to B over sine B equal to C over sine C. Now let's look at the activity. They say show that angle A is close to 32 degrees. Show that angle A, which is this angle, angle A is close to or equivalent to 32 degrees. I am given what? I am given a full, complete length as well as the angle. And I can see that A is opposite to the side that is given, meaning I am going to use the sine rule for me to find that. I cannot use any other way. I will use the sine of the angle. So when I'm calculating, I am going to write my sine rule. Sine, whichever way, I can start with the side over the sine of the angle, or sine of the angle over the side. I am looking for the angle of that angle. So I say B over sine B equal to A, side A, over sine A. And I substitute the information given to me. My side B is 99 centimeters over sine 82 degrees equal to, I am given the side 53 centimeters over sine A, because it's what I'm looking for, over sine A. And for me to calculate this one, I will cross multiply. I will cross multiply like this. And when I cross multiply, the sine 99 multiply the sine A to give me 99 sine A, and the 53 multiply sine 82 to give me 53 sine 82 sine 82 degrees. And remember, I'm looking for what? I'm looking for angle A. So what is blocking me? Divide by 99, both sides. Divide by 99, both sides. 99 is gone. I'm left with sine A equal to 53 sine 82 over 99. And when I am pressing that on my calculator, I press that on my calculator, 53 sine 82 it's 53 sine 82 divide by 99, and it gives me 0,5301, and that is what I'm getting. And I find because I'm looking for the angle here, I'm still left with the sine on the other side. Can you see that? When I simplify this one, it gives me 0,53014311. That is still what? Sine A, not angle A. It's sine A. And I must get rid of the sine. And when I take sine from this side to that side, I take it, it becomes sine inverse. I will have sine inverse, and I'm left with A. I'll be left with A here, equal to sine inverse of what? Of 0,5301 and many other numbers. So on my calculator, I will press my sine inverse, you say second function, sine bracket 0,530,1435 close, and there you've got your angle as 32,0151,518, which is equivalent to angle 32. So when I press that on my calculator, I get 32,015 and many other numbers, which is equivalent to 32, because the question said I must show that A is close to 32. It is close to 32 degrees. I can see. Next question. They say calculate the length of X. I have a full length given, a full set given, which is what? 60 degrees, going with the side 7 centimeters. I'm given the angle going with the unknown. Again, I am going to use the what? The sine rule, where I will say X over sine 80 equal to 7 centimeters over sine 60. And I cross multiply here to get what? X sine 60 degrees equal to 7 sine 80 degrees. And because I'm solving for X, divide both sides by sine 60. Divide by sine 60 degrees. Sine 60 degrees, which will leave X as the subject of the formula there. And I press my calculator. 7 sine 80 over sine 60. 7 sine 80 7 sine 80 divide by sine 60 degrees, and I've got my value as 7,960106298, which I can round off to 8, which means my value for X is about 8 centimeters. There I have calculated it. Moving on to the sine rule. Sine rule can be used when you are given two sides and the angle is included. You are given the side and the included angle, which means on your triangle, you must be given the two sides. Here is your triangle. On that triangle, the included side is this one if I am given this side and that side, which means I am looking for this side. This side is the one that I'm looking for. And you will notice that the side that you are looking for, the angle is given, meaning when you are writing your formula, you will start with the side and end with the angle of the opposite side. That's why we say for you to use a cosine rule, you use cosine rule only if two sides and an included angle is given, or the lengths are all three given. The lengths of the three sides are given. And the formula that you are going to use, if they give you, let's say it's triangle ABC, you are given the angle, it means it's the side A that you don't know. You will start with the A and end with the A, where your formula will say A squared equal to the side that is given, B squared plus C squared minus 2, and you find the product of the two given sides, and multiply it by the cos of the given angle, which is included there. So it's A squared equal to B squared plus C squared minus 2BC. Can you see the B and the C? I multiply them, and cos of the given angle, which is included. But if C is what I'm looking for, can you see I start with A, I end with A, angle A. If C is what I'm looking for, the side C, I will say C squared equal to A squared because I'm given A and B as the sides. So I will say A C squared equal to A squared plus B squared minus the product of the two. 2AB cos C. I start with C, I end with C. If I'm given B, I will say B squared equal to A squared plus C squared minus 2AC cos B. And that is my formula for the cosine rule. And remember, I said to you, you must either be given two sides and the included angle. By included, you cannot be taking it, let's say you have a triangle here and you are given this angle, and the sides that are given is this one and that one. This is not included angle. The included angle is the one that is falling in between the two given sides. You must have the two sides and the included angle, or you can be given all three sides and you can use cosine rule. And remember, I said to you, you must know when to use which rule. I said to you, for the sine rule, you must have a complete set of the angle and the opposite side, and one angle or the side for the other to use sine rule. But for cosine rule, it must be two sides given with the included angle, and or all three sides must be given, and you can use cosine rule. That is what I am trying to show you. You can see here I have triangle, my triangle with the side facing A, which means the one that I'm looking for is A, and I have the angle and the two sides B and C, and you can see A is between B and C. So the formula that I'm going to use is going to be A squared equal to B squared plus C squared minus 2BC cos A. And I solve a triangle given two sides and angle or three sides. Here I'm given two sides and an included angle. Let's look at activity 3. They say calculate the length of H in the diagram below. Here I'm given two sides and the included angle, and you can see H is opposite the given angle. For the next one, we have to calculate, they say calculate angle A. Angle A, you can see angle A is between 15 and 12, and I'm given all three sides. I must calculate. Let's start with the first one, where I am calculating the side A. And I said the formula that I'm using is cosine rule. The side that I'm given is the, I'm looking for is this one. And I will start with this angle, and the angle that is facing it is the one that is included. So it's in between the two sides. So I will say H squared equal to 88 squared plus 146 squared They're centimeters, units, minus 2 into 88 centimeter times 146 centimeter cos of the included angle, which is 53 degrees. You can just take your calculator and press all that in your calculator, where you will be pressing in your calculator. I'm looking for H. I said 80. I must start by bracket because it's squared. 88 squared plus bracket 146 squared minus 2 into brackets 88 close bracket 146 close cos of the angle, which is cos 53, cos 53, and right away I get my H squared as 13,595,76117. Remember, that is still H squared, and I am looking for H, not H squared. What do? I find the square root, remove the square by the root, its inverse. So I will say square root 13 595, 76117, and it gives me 116,6, which is the value of side H. It's 116,6. They didn't say I must write all it to which, how many decimal places? It's 116. My H will be 116,6 centimeters, which I can round off to 117 centimeters, depending on my question. But my question is not stating whether I must round off to the whole number or to 1 decimal place or to 2 decimal places. If I put 2 decimal places, it's going to be 116,60 because it's followed by a 0. So my answer can be 117 or 1160 to 2 decimal places because it's not stated. So if it's not stated, I can round off to 2 decimal places. All right, the next one, they say I must calculate angle A in the diagram below and leave my answer into the nearest whole number. Can you see? They specify here. They need the answer into the nearest whole number. So I use my formula. What am I looking for? I am looking for the angle A, this one. So it means I use my formula, which will start with the side that is opposite A, 20 squared equal to, that is the side, the two sides, 12 centimeter squared plus 15 centimeter squared minus 2 into what? The 2 into 15 by 12 cos A, which is the side that, the angle that I'm looking for. And you can see that when I am working, the unknown is here, is cos A. It's angle A, cos of that angle. So I must start by adding the 2, and I transpose them, and I will get rid of everything. At the end, I must be left with with A, the angle A, and I must solve for it. So this one, I will transpose everything. You can see I'm having 12 squared, which is 144, 15 squared, which is 169, and I will transpose. I will have 20 centimeter square minus 12 centimeter square plus 15 centimeter square all together minus that 15 centimeter square. Equal to what is left there. That side I'm left with negative 2 into 15 times 12 cos A. And because I am looking for that A, I will divide everything by that negative 2 into bracket 15 times 12. So I will have 20 square minus, in actual fact, let me make my life easy. Let me just calculate the 20 square, which is 400, minus 144, 400, minus 144, minus 169, all over negative 2 times 15 into 12, which will give me cos A. And because I'm looking for angle A, I will take cos to this side, and it will give me cos inverse of the answer. The answer that I am getting is gonna be 400 minus 369 over 360. 400 minus 369 over negative 360 equal to A. And when I press that into my calculator, I get my A, angle A, equal to 85 degrees. I get my angle A as 85 degrees. That's how I calculate the angle. Let's go to the area rule. Remember, I said to you, when calculating the area of a triangle, you must have a perpendicular height, which is this one. This is your perpendicular height. And you must have a base on a right angle triangle. For you to calculate using A equal to half base times the perpendicular height. But if you don't have or you don't know your base or your perpendicular height, then opt for what? Opt for the area rule. Area rule is used when you are given the two sides and the side of the angle between the two sides. The area rule, the area formula can be used for any triangle if you know the two lengths of the two sides and the size of the angle between those two sides. Meaning, here I have my triangle with this side given, this side given, and the included angle. So I will use area rule. If I am having my triangle ABC, A, B, C, my formula is going to be half the side that is given times the side that is given sine the angle that is included. You know that this is small letter B, this is small letter C. So it means if I'm given that angle, my area rule will be triangle ABC will be the area of triangle ABC will be half of what? I'm given B and C. B times C sine A, because A is the angle that is included there. If I am given angle B, it means I will be given C, side C, and side A. So it's going to be half A, C, sine B. If I'm given angle C, if I'm given angle C, it means I will be given side A and B, which is going to be half A, B, sine C. So that is your area rule. You are looking at the two sides that are given with the angle in between them that is given. So it means that is the angle that you will end with when writing or when calculating the area of a triangle. That is done only if you don't know your perpendicular height and you don't know which one is your base. Then you cannot say half base times height. You will go for the area rule like that. You can see here I am having 63 as the angle given between side B and side A, meaning my formula is for this area of this triangle is going to be half A times B sine C, which is the given angle. Let's look at the activity. We are given, or we are required to calculate the area of triangle ABC, where we are given the side, small letter A, side, small letter C, and the angle B. That angle B is 42, and side A is 7,1, side C is 5,2. So I will use the area rule. Same as B, where I'm required to calculate the area of that triangle given side 28 centimeters and the other side 22 centimeters, included angle as 97 degrees. So I will use my area rule. Area will be half given side, which is gonna be what? A, and I'm given side C, sine of angle B, because it's the angle that I'm given. So what is the value of A? It's half. My A is 7,1 times my C is 5,2 sine 42 degrees. And I will just go right away to my calculator and calculate half times the angle that, the side that I'm given, 7,1 times the other side that I'm given, 5,2, and times sine 42. And there I've got my area as 12,352,15099. That is my my area. It's 12,532,15099. The other one, where I am calculating, I said it's 12,35. I round off to 2 decimal places. That is my area. And remember, area is calculated in square units. So my area is the side, which is in centimeters, and the other side, which is in centimeters. They multiply and give you a square unit. The other one that I'm calculating is using the area rule. I must calculate, okay, area rule. First, I write the formula: area equal to half side given 22 centimeter times 28 centimeter sine 97 degrees. And I just press it on my calculator and it gives me 305,70,42147. I just round off. It's square units. I round off to 2 decimal places. It's 305,70 square units, because it's an area of a triangle. Area of a triangle. Remember, in order for you to get used to whatever that is done in the lesson, you must practice it and practice it up until you grab the content. I have given you the worksheet that I want you to practice over there, where I want you to draw a right angle triangle. You let angle ACB equal to angle beta, and you identify the opposite, adjacent, and hypotenuse of your right angle triangle. And I want you to write the ratio of sine beta and cos beta. For opposite side, you use OPP. For adjacent side, use ADJ. For hypotenuse, use HYP, and you draw that triangle. You write the ratios of the sine and cos. And question 2, if 2 cosec theta is equal to 10, where theta is an element of 90 and 360 degrees, you calculate sine square theta plus cos square theta, 10 theta, sec square theta. And I will also want you to use your calculator and complete the table over there, and then you see what you notice when you when your answer is 90. What do you notice on your angle theta when you have 90, and what does that mean? And you calculate, you identify which rule to use to calculate the area of triangle MKN, and you round off the answer to the nearest whole number. Remember, I say to the nearest whole number. And for the other one, question 5, I want you to calculate the length of PQ, and you correct to 2 decimal places. Identify or think which rule to use when you are given that information. Is it going to be sine rule? Is it going to be a cosine rule, to find the side that you don't know over there? And that marked the end of our lesson today. Thank you so much. Enjoy your day and keep on practicing.